Today what we're going to do is we're going to look at two different types of rates. Whenever we've talked about rate before, what we've talked about is the nominal rate. And what the nominal rate is just the basic rate in our formula. So we have our compound interest formula, where we have our initial amount, we have our rate, and then how many times it compounds, raised to how many times it compounds times the time. Our effective rate is the actual rate based on the compounding. So what it's doing is it's looking at this part of the formula. And this part of the formula is what our effective rate is. So if you look, our effective rate is 1 plus our nominal rate over how many times it compounds raised to how many times it compounds. Now, because of the plus 1, we're subtracting 1, and that gives us our effective rate. So the more times it compounds, the greater our effective rate is going to be. The formula works exactly the same with the continuous function. What we're doing is we're using the number e, we're raising it to the nominal rate, and then we're subtracting 1. So if we look at our first example, what we have is a person investing $10,000 in a mutual fund at a rate of 10.5%. Now, when it just basically says rate, we're assuming nominal rate. The only time that we're going to assume effective rate is if it says effective rate. So in this case, we're finding the effective rate. We have our nominal rate, which is just our rate, and it's compounded quarterly. So since it's compounded quarterly, what we're going to do is we're going to use our first formula, and we're going to go effective rate is equal to 1 plus our nominal rate, which is 0.105, over how many times it compounds. In this case, it compounds quarterly, so we put a 4 raised to the 4. What we're going to do is we're going to take our calculator out. We're going to plug this formula into our calculator, and we got to make sure that we subtract the 1. And that right there, when we turn it into a percent, is 10.92%. Now, the effective rate is always going to be larger than the nominal rate. So we see that this is 10.5%, this is 10.92%, so we know we're on the right track. Now, if we look at our second example, this time what we're doing is we're finding our nominal rate, and they tell us that the effective rate is 4.3%. So that means we're going to put 0.043, that's our effective rate, is equal to 1 plus, we're trying to find our nominal rate, and it's compounded semi-annually, so we're going to put a 2, and then we're going to raise it to the 2. And don't forget subtracting 1. Our first step is we're going to add the 1, so we get 1.043 is equal to our 1 plus r over 2 squared. Now what we have to do is we have to get rid of the squared. So we're going to do the opposite operation, which is a square root. And what we get is 1 plus r over 2 is equal to, remember I'm putting the rounded value, 1.02, but on my calculator I have the exact. I'm going to do 2 steps in one. I'm going to first subtract the 1, and then I'm going to multiply it by 2 on my calculator. So I subtract the 1, I multiply it by 2, and I get a rate of 4.25%. Now remember, the effective rate is always more than the nominal rate. So if we're looking at this, 4.3%, 4.25%, notice that there's just a little difference. And the reason that there's a little difference is that it's semi-annually. So it's only compounded twice a year. Nominal rate would be just once a year. So examples 3 and 4, we're going to be using our second formula. And how we know that is it says compounded continuously. So we're going to use our continuous formula. We're trying to find in example 3 our effective rate, and they give us a nominal rate of 7%. So we're going to go effective rate is equal to e to the 0.07, and don't forget to subtract the 1. We put that into our calculator, and what we end up with is 7.25%. Now, our last example. This time what we're trying to do is find our nominal rate. It tells us our effective rate is 9.1%. So we have 0.091 is equal to, once again, compounded continuously, tells us we're using our second formula, e to the r. Remember, r is our nominal rate, or our rate. And then don't forget to subtract the 1. We add the 1, and we get 1.091 is equal to e to the r. Now what we need to do is we need to get rid of the e. So in order to get rid of the e, we're going to do natural log, because remember, natural log is log base e. That becomes 1, and we do the natural log of 1.091, and that right there gives us 8.75%.